So we're asked to find the limit of x squared minus 9 over x minus 3 as x approaches 3. Now, what you might be inclined to do by looking at this, if you know how limits work, is to say, oh, look, the power up here is bigger than the power down here, so that means that this is to equal infinity. But that's not what we're going to do. If you don't know what I'm talking about, check the videos on limits. But we got to be careful about the bounds of our limit. We're not going to infinity. What I just said is only applies if this function was going to infinity. We're going to x equals 3. So if we were to draw the graph of this function, which I'm just approximating it here, but if this was the graph of the function, we'd want to know what value is it approaching as it approaches x equals 3. So the first thing we should always do when trying to find the limit of something at a point that isn't infinity is to just put it into our function. So let's see, x minus 3, so that'd be 3 squared minus 9 over 3 minus 3, which is 0 over 0. Now that's an indeterminate. That doesn't tell us that the function is undefined if the limit exists, it doesn't exist. It tells us that there's stuff we could do to find the limit at this point. It's just we can't find it while our function is in this form. So there's two things we can do. If you're a little bit further in calculus, you can use a little rule we call L'Hopital's rule. But if you don't know L'Hopital's rule, the easier way to go about this is to just try to cancel out this x minus 3 on the bottom. So we do the limit as x approaches 3, and we can expand this top because this is an a squared minus b squared into an a minus b to an a plus b over x minus 3. And look here, what do we have here? We have x minus 3 and x minus 3. We can cancel those two out and leave ourselves with the limit. This limit here is equal, because this is all equivalent, to x plus 3. Sorry, that I miswrote 9 here. It's supposed to be an x plus 3. And then we can go back to what we did up here, where we just substitute the x into our function. So that'd be x plus 3 becomes 3 plus 3, which is just 6. So if we were to plug this into our graphing calculator, we'd see that as the function approaches x equals 3, it gets closer and closer to y equals 6, and then when it actually gets to x equals 3, it might be a hollow dot there to signify that it's undefined specifically at that point. But if you were to fill in that dot, it goes smoothly at y equals 6. So the limit as x approaches 3 of this function here is 6.